Okay, dear scholars, once again, let us continue with the class of biology. Of course, this is the class for advanced learners, senior 5 and senior 6. Let's continue with genetics, and we are going to begin right away from where we started, from where we stopped, and then we shall be proceeding. When I concluded the last time, we had looked at the monohybrid cross, and of course, I ended with conclusions from the monohybrid cross. So, those people who are following, you could be knowing what we concluded with. I may not go there, but I will just add on. Now, the other important thing is all those conclusions about the monohybrid cross were then summarized by Mendel into two general statements. So Mendel summarized all those conclusions into two general statements called Mendel's laws of inheritance. I can simply write that the conclusions from the monohybrid cross, from the monohybrid cross were summarized by Mendel into two general statements. Into two general statements called Mendel's laws. Mendel's laws of inheritance. Mendel's laws of inheritance. These laws are two. We have the first law of inheritance and then the second one. The first law, or we can call it Mendel's first law. Mendel's first law of inheritance. Mendel's first law of inheritance. This one is also called the law of segregation of genes. The law of segregation. Law of segregation. Law of segregation of genes. Law of segregation of genes. Or law of particulate inheritance. Law of particulate inheritance. Law of particulate inheritance. Mendel's first law of inheritance, also called the law of segregation of genes, or the law of particulate inheritance. It is called the law of particulate inheritance simply because at first all the earlier scientists, including Mendel, they first called the genes particles. They first called the genes particles or factors. But now, as biologists advanced, or the biologists who followed Mendel, then called those factors or particles genes. And that's the law of segregation of genes, or law of particulate inheritance. Now, this law states that organisms' characteristics are controlled or determined by alleles which occur in pairs, and only one pair can be carried in a single gamete, and this is assured by meiosis. That is Mendel's law of segregation of genes, that organisms' characteristics are controlled by alleles which occur in pairs. Only one allele or only one member of the alleles can be carried in a single gamete, and this is assured by meiosis. That is what we call the law of segregation of genes. So I can write that states that the organisms characteristics are controlled or determined by alleles which occur in pairs, only one member of a pair, can be carried in a single gamete. This is assured. By meiosis. That's what we call Mendel's first law of inheritance. So, organisms' characteristics are determined by genes which occur in pairs. But during meiosis, the genes segregate, or the genes separate, and only one member of the alleles of a gene can be carried in a single gamete, and this is assured by meiosis. That is what we call the law of segregation of genes. So the other one is Mendel's second law. Mendel's second law of inheritance. This one is also called law or principle, law of independent assortment. Law of independent assortment. Law of independent assortment. Mendel's second law of inheritance, also called law of independent assortment. The word assort means rearrangement. The word assort means rearrangement. So it means those alleles or those genes after segregation assort independently. They rearrange to form new allele combinations or to form new gene combinations. Now, this law states that each member of allele pair, can combine randomly with either allele of the other pair. Each member of a pair of alleles can combine randomly with either allele or with either allele of another gene pair. So I can write that states that each member of a pair of alleles, each member of a pair of alleles, can combine randomly with either allele of another pair. Dear scholars who are there, who are looking at this work, that is how those two laws can be stated clearly. So, of course, we know that we have genes here. So we can simply say that alleles or alleles of one gene pair can combine randomly with either allele of another gene pair. But here we simply state it very well and clearly that each member of a pair of alleles can combine randomly with either allele of another pair, what we call the law of independent assortment. So what happens? This law is applied in dihybrid inheritance. So the applicability of the Mendel's second law of inheritance, or the principle or law of independent assortment, lies in dihybrid inheritance, whereby the genes separate at first, then after separation, these genes independently assort, or these genes rearrange themselves or recombine to form new allele combinations or new gene combinations. And this process can be termed as genetic recombination. So it is from this basis that we talk about genetic recombination. So a question can be fired to you that explain what is meant by genetic recombination. So from here, you can be able to answer the question. So that is what happens. So that is the summary in which the conclusions about the monohybrid cross have been put actually into two general statements as shown on the board. So, from that, we are going to have a simple question about the monohybrid cross. So for that matter, I will first need to clear this board very fast, and then we continue. So if you can recall, the monohybrid cross, it has two generations. It has the first generation called F1 generation or filial 1 generation, and then it has also the F2 generation or second filial generation. And briefly here I will say that in the F2 generation, the phenotypic ratio is 3:1. 3 tall peas or 3 tall pea plants to 1 short pea plant. That is the phenotypic ratio in the F2 generation. So now, let me organize the question here. The question is, considering the monohybrid cross question, considering the monohybrid cross, monohybrid